going to re-square this. Now I want the hold up. I want these two holes up here. Then this one I want way down here at the bottom. So I have kind of a triangular effect. That way things don't slip out of adjustment where you set them. I wish they'd go 100% of Torx on everything. No flats, no fill-ups, no reed prints. All right, I want this hole down at the bottom as a third location. A little black RTV or something of that nature. But I don't think anybody will even notice it. There you go.
Dang. Dude, that looks good.
Now, where's our two of these? Now, just for insurance, I'm going to put a little bit of low strength Loctite on these. Low strength Loctite is the pink, number 272. They don't jam in so tight that you got to heat them up with a torch or a heat gun to get them out. But it sticks pretty hard too. If we didn't screw up, this ought to go right on now. You got to have adjustment, huh? Lots of editing to do. All right, test it, Noah.
How you want me to test it?
Yank on it.
Dude.
It's solid.
Damn. That ain't going nowhere.
I really do believe, though I haven't tried it, you could stand up on that and jump up and down on it.
Low key, you could. Wow. Yeah, that is solid.
Tight. Now we're firmly hooked up here to hang our transducer on. It's got plenty of offset from the center of the motor. We like to have 12, 14 inches. And we got a little height from here, so it's not going to be dragging in the water. It may be skimming the water, but it won't be dragging in the water. And it's actually designed to be a skimming transducer, so that when you're graphing like 20 miles an hour, it will still read. The through bolt, be sure you put the rubber washer in with the steel washer on it, and you don't want to get this so tight that it won't move. If you hit something, you want it to kick up. Or somebody falls on it or something like that. But I want stiffer than that. The rubber washer will compress, kind of like a spring. Okay, that's too much. There we go. It's hard to move, but it will. So hit a log or bump up or somebody falls on it or something, it doesn't break something. And this is a personal thing. I'm adjusting it level. If you want to shoot straight down, you want it level with horizontal with the water. My boat, I have mine set up so it's pointing kind of forward like that. So the beam at 20, 30 foot deep is under the boat. When I'm fishing up front, if I'm slow dragging a bait, the bait's back under the middle of the boat. If you tip it forward a little bit, now I see the bait when I'm up front from the trolling motor. Is that the way you would like it?
It's on you.
All you got to do, if you want it to look further back, pull it up one click. Attach it to that to pull that one a little further up. Got to think through all the other things.
So you're gonna have to do this more than
Well,
once.
I need to get 3 wires pulled, so I need to pull 3 wires of the proper length out to here, and then from here we'll pull them up front, because I think I can keep the fiberglass rods all the way back to here. I guess that's what I need to know now, is can I get the fiberglass rods back here? They have their purpose too, but so do these. These are inexpensive. You can get them from Harbor Freight, get them from Amazon. And I recommend anybody that gets them, get 2 sets. Because the one set's quite often not long enough. Not enough rods in it, so you get 2 sets. But buy them at the same time from the same supplier, because the threads on here are different. So if you get a set of Harbor Freight, I have a set of Harbor Freight, 1 set, and they do not interchange with these rods. So you need all the same threads. Because as we run these, we're going to try to run these back there all the way to the back. So you keep adding a little, pushing it, pushing it, pushing it. When it comes out the other end, now you can hook up to a rope, you start pulling the rod out, you can take them off in pieces. A long continuous rod, you can never do that. So it has to be a bunch of rods added together. And that's why I got 2 sets, to make sure I always have enough of it. But I'm going to try to go through the rod locker all the way back to that hole. I think I can, in the boat. And then I can get a pull rope attached, and I pull the pull rope in place. Because you don't want to try to pull cables with these. They're not that strong. You'll end up breaking them. So I get a pull rope in. It's got plenty of strength to pull the transducer cable and the wires that I need to pull up here all at the same time. So that's the goal. So you're going to kind of keep an eye out for that, maybe back there, where I'm trying to get enough rods to go. But basically, always keep in mind, there's always a way to go down the gunnels. And when you're running cables for electronics, you don't want to run them down the port side of the boat, because that's where the trolling motor cables are. And you'll get electromagnetic induction into the harnesses. You'll have interference on your fish finders. They need to be on the opposite side of the boat.
That's an important tip.
That's very important. Now, some of the newer boats have a tube right down the bilge, all the way to the back. It goes right up the center of the boat, all the way to the bow. But what I don't like about that is it doesn't break out in this area to install a fuse box near the console. So when I get to those, I'm usually running the harness down the gunnel.
Don't let that door fall and hit you.
There, got it started. You have to have it really high up to get into it. So far, so good. This might be just enough. And I just need it to that small hole back there.
So are you just gonna leave that rope in here for?
No. We're gonna hook the wire and the transducer up to the rope
Okay.
and pull it through.
Okay. Yeah.
And I'll pull the wiring I need to connect the battery through. At the same time, I pull the transducer cable up all at one time. Now these you have to be careful. They only bend so far before you snap them in two. When you put tape on, you need to think about how you're going to take it off. And I'm about to show you a trick that makes that a whole lot easier. Pull on it, make sure you can get a good pull on it. But if you pull the tape out, give yourself a few. But anyway, as you come out, just unscrew them, take them apart. You get too much of it out, bend too very much, you'll snap the brass pieces off that connect them. They are semi-fragile, but they did the job. They got the rope in there. And the rope you don't have to be gentle with. You can pull it hard as you want that rope. You'll never break that rope. It's like 1,200 pound snap and break strength on it. Commercial electricians use that stuff all the time. Oh, you are right here. Now, if you put tag end on it, like I just showed you, this is how easy it is to take off.
Nice.
If you laid it down flat, it would be all stuck together, and you'd be here for 10 minutes. I got saw and the starboard side rod locker. We got 10 gauge wire. In this case, it's going to be more than sufficient for the electronics on this boat. And it leaves plenty of room for growth. So if you decide to put bigger, badder units on it or more units on it, it's going to have the current carrying capacity that might or might not be needed.
So what is the purpose for you twisting these wires right now?
Twisting the wire reverses polarity. The wire has a magnetic field around it. North and south pole, just like a magnet. This is emitted from EMI. When you twist them, because of the way the poles keep crossing, north and south cross, when north and south come together, they're repelling each other, but they will cancel it in the opposite wire. So it's canceling interference that may be picked up or generated in the system. The thing about interference, if you want a good job on wiring on your boat, you do everything you possibly can to prevent it. If you can find the source, the best thing to do is eliminate the source. But that's next to impossible because there's too many different ways that can get into the system.
So what does interference look like when you're dealing with your electronics?
Something normal that it's not a fish, it's not a rock pile. It can look like snow on a TV screen. It depends on the frequency of it and how it's contacted and what it receives, because it could come back as an image on your screen. So it could be vertical lines, it could be evenly spaced if it has a steady frequency. It can be a horizontal line going across the screen, but it's usually multiple lines, and sometimes it's a lot of lines. An active target or live scope, because of the frequency used and the speed, it can be semicircular rings flashing across the screen, say every 2 seconds or every 5 seconds. It can also be, I see a band of, looks like bait fish, but a whole band of bait fish going from the upper right to the lower left, but it's always there. No matter how you turn the motor, how deep the water is, that band is always there. That's interference. It's coming for something.
So a lot of people complaining about their front-facing sonar not being clear. It's possibly due to
Not
improper
taking
wire
all
harness.
the steps that they can.
Yeah.
And there's so many ways to control it. You take every step you know of. Ferrite rings is another common thing that's done. I'll show a picture of those later because I will install a few ferrite rings in this in key spots. But it's nothing more than a magnet that goes around the wire, and it greatly aids in canceling interference as well. And you don't know where it's going to come from. And a lot of times it comes from your own devices. For instance, the consensus is to use forward-facing sonar and to keep interference to a minimum, that you absolutely must turn off side scan and down scan, because it will show up on the screen. The frequencies are too close to the same, but it's not from the same unit. It's coming from another source. So it's noise on the screen. It's an abnormal picture if it's not clear image. So you have things on the screen that don't belong there. It's not something in the water, and it's not something that you're looking at. It's from an outside source. But you take every step you can. Proper wire size, proper shielding, really good connectors, good high quality wire. Even a poor connector, it's not tight, can cause micro arcing, where think of it like micro lightning bolts jump in the gap in the small connection. That creates interference. It creates the RFI when that happens. So connection quality is really, really important. Don't buy cheap connectors. And get really good crimping tools to crimp them down properly. They gotta be tight and snug. The twist on this doesn't have to be exact. Roughly 3 to 5 twists per foot is what you're out to achieve. Doesn't take a lot of twisting. But everybody should Google this. They want to learn more about it. And you hear old CB operators, ham operators talking about the twisted pair. Well, the twisting pair was a landline telephone where you'd pick that phone up in the house and you pick it up and you hear a constant dial tone. The dial tone was a carrier. They put a low-level carrier voltage in it, which we would hear as a dial tone, but that also would hide interference because it was a low-level constant voltage, and for conversation, they would only use the voltage above that level, which is a very sneaky way. I've seen this in automotive used on many things, like wheel speed sensors. ABS sensors are really critical to interference for your ABS braking system. And I was working for Ford when they first started doing that. I said, what the hell are they doing here? And then I got to thinking about it. That's a carrier voltage, because the interference is a lower voltage than the carrier. Well, the programming would ignore the carrier or anything below that level. It would only look at what was higher than that level. And that solved a lot of problems with wheel speed sensors.
Go ahead.
We got our 3 wires twisted together. The red, big, red, black are 10 gauge. That's the power ground wires. This black one is a drain wire or case ground, whatever you want to call it. If it's Hummingbird, they call it a drain wire. If it's Lowrance or Garmin, it's called a case ground.
You're talking about that brown wire
This
there?
brown wire, it's
Okay.
a little smaller. This wire cannot carry current. Cannot. So you cannot hook that drain or cast ground to this black wire. That wire carries current. It won't bleed off the RFI that's collected in the system that way. It has to go straight to the battery. And a lot of the instructions will tell you for grounding a shield and that to ground it to a chassis. Well, fiberglass boat doesn't have a chassis on it, so you can't attach it to a metal frame or sheet metal body. you got to run it all the way back to the battery and hook it to the battery. The only way to do it, and for it to work. Well, so now we're going to put the shield on. After I get the shield in place, then I'm going to show you how to attach a ground wire to it properly. It has to be grounded, and it has to be grounded good. Then when we get that done, we're going to put shrink tube over the whole thing, because you need to protect the shielding. So, it takes a little bit of patience. We'll probably edit it out, won't show the whole thing because of how much time it takes. But I'll get this started spreading it. And think of these like Chinese finger cuffs. If you push on them, they get a lot bigger. So you see the concept when I start feeding it over the wire. Got to get it big enough to start it. And you start putting it. If you pull on it, it just gets real tight, and it may go a little bit, but it won't go very far when you pull on it, because it'll pull down tight like finger cuffs will. So you have to get back here somewhere and push on it. And once it starts getting to where it's getting more grip on your wire, then see how it bunches up? Pinch it off, pull it forward. Push it up, and then pull it forward. And just keep doing this till you have it all on there. And then keep an eye on your shield. You don't want to fuck it up. Oops, sorry about that. Editor will take it out maybe.
What a beep. Beep.
So keep the twist out of it, because you can really mess this up if you can't get it flat to where it's almost impossible to get on. So keep the loop. So you're hitting at two angles to get your system as trouble-free as possible. The sound system and video industry has been doing this for years. The automotive field, which I come from, has been doing this for years. So I learned about this years ago, and I started applying it to my wiring harnesses and boats, and it's worth it. You have to address interference in every way possible, because you never know exactly what's causing it, where it's coming from. So you take every precaution you can. In some cases, like a hummingbird especially, you add some chokes. Low-pass filters is what they're technically called, on the power wires, especially on the battery charger, because the battery charger causes problems too. Even though it's not running, it creates what we call a ground loop, and low-pass filter will help resolve that. Ferrite rings on the transducer cable, near the transducer, and near your MFD on each end of it, and you just clip them over. Just clip them over the wire, snap them together, and then put a zip tie on them to make sure they stay in place.
What are ferrite rings?
Basically, they're just a magnet. And think of it as it's a barrel-shaped magnet, and it's split in half. And they have north and south poles. Well, the magnetic field from that ferrite ring can cancel interference that does escape these other precautions that's in the wire.
And then you put those, where do you place those ferrite rings again? On either side?
Yeah, you want to put them near the source, like in a transducer, you put them near the transducer, and you'll put another one on the transducer cable up near where it attaches. Both ends of the harness, whether it's on the transducer cable or you actually put them on this, because you can put them in this cable too. Though usually I don't find them necessary. If I've twisted and shielded the wires, I don't find them necessary on this harness.
Where can you buy this shielding from?
I've been getting it at Amazon. But get the 3/4 inch. Don't go and get 3/8 or 1/2 inch. you need it about the width of your harness, because when you pull this down snug, you want to close up most of the openings in the braid. And if you get the small stuff, when you push it on, it spreads it and it opens it up. There's entry path, small holes of entry path into the whole thing.
Mm-hmm.
So it's as compact as possible. And then we'll install the ground wire on it. Okay. I don't want it loose and sloppy. I want to try to pull it down snug. I may have to trim some on this end. If I have to, I will. Now this end's going to go to the fuse box. Yeah, I need to take a little bit off here. A good pair of Kershaw scissors will cut this stuff just fine. That should be about right. Now I'm going to pull it down snug, so I'm going to pull down snug on the wiring. I want to shoot the shrink tube to go with this nicely. And I'm going to tape it off so it stays where I got it. Some of you guys in trimming wire, you may have seen this stuff or foil wrap around the wires. The foil wrap does the same thing, but not as efficient, because usually the foil wrap is not grounded, and it should be. But it still does help. The shielding works far better than foil wrap does. Okay, now I'm gonna make a ground wire. And in order to keep things kind of identified separately, the brown wire known as the drain wire. I will use a small black wire for the shield ground.
Does the gauge of wire for the ground, for the shielding for the ground, or the grounding for the shielding, is that
Not
pertinent?
a big deal
Okay.
on it. However, I like around a 14 gauge. That's exactly what that one is. That's what I normally put on them, because I want a heavier wire and a heavier connector to terminate on the end. I don't want a real wimpy wire that's prone to getting broke, and a wimpy connector that doesn't work well. That's why I kind of choose that size of wire. All right, cutters. I'm going to put it in this end, because if I put it in this end, it's easier to run the shrink tube over it. A little bit more. I'd rather waste a little wire than come up short and have to splice it. And what you're after is you're going to strip several inches of this wire. You want nothing but copper strands to wrap around that wire.
Mm-hmm.
I prefer not to cut copper strands, but if you cut a few, it's not a big deal. Some wire strips easier than others like this. It's actually on that tin copper pretty firmly. And if you have to, you can slide a razor blade down it, the side of it, and split it and make it easier yet. But if you go too small, you'll cut the strands and you'll have wire strands coming out everywhere on you. But a little practice, you get better at it. Don't try to take too much off at one time. If you take your cutters and you can feel it cut the wire, rotate it a quarter turn and do it again. So it cuts the wire all the way around, then pull on it. Because if it's not cut all the way around and you try to pull it off, it won't pull off. That's almost enough. A little bit more for good measure. I will retwist this wire. Is conductive shrink wrap. This is a special shrink wrap that shrinks and it's conductive. It conducts electricity just like the wire does.
Get that on Amazon too?
Yes, you can get it in Amazon too. They have it. Different sizes, different widths. This is actually a little bit on the wide side, but it'll work. It'll get the job done.
It's good enough for farm work?
Good enough for farm work. And heat gun will shrink it and seal it, both. Now, I need a razor blade handy, like this. Insulation back in here a ways, because we're going to seal over the end of it. We don't want water migration destroying our connection. And then we're going to take this and wrap it around the shield several times. This ensures that we're going to have a good connection between that wire and that shield. If this is not done right or not put on there, that shield will actually work like an antenna and it won't be able to get rid of RFI collected. It'll collect it and now it's trapped right around your wire. But the ground bleeds that RFI and EMI, it bleeds it off. Now we're going to wrap it with that and shrink it. So you kind of got to hold things together when you're doing this. guys think this is just shrink tubing. It's not. Very important. It's conductive wrap. Any current, it's there, it will conduct it and complete the circuit to ground. Okay. Now, this stuff's got sticky stuff on it, so as you shrink it, the sticky stuff will all bond together. What I should do is just cut off a piece of this instead of trying to manage the whole roll here. Kind of reminds me of a motorcycle inner tube. It handles and reacts, except it gets all sticky when you heat it.
I was going to say it looks like a fruit roll-up.
It looks like a what?
A fruit roll-up. You don't know?
There you go.
You know what a fruit roll-up is?
Yeah. So I'm going to overlap the end of it. I need to get that piece of that tape off there so it don't interfere with the sealing. So it'll make you feel like you're all thumbs doing this. Because I'm trying to pull this on very, very tight, as tight as I can get it over it. Now, don't burn your fingers when you're doing this. You're going to be very close to your fingers. You see down here how it shrank down? But you can push the air bubbles out and keep pushing it down, flatter. See here how it shrank? That's shrank and sealed right there already. So as you start progressing down it, you're kind of pushing it in place, try to get the air pockets. You want it down snug. See it start to shrink? In one place curled back on me. But if I take it, stretch it over it, push it in, now that it's sticky, it'll start locking in place. Get nice and close, you get lots of heat in it. That bubbled up on me. When it's still soft, I'll push it back and hold it for a minute. Sometimes little spots. I can need more pinpoint accuracy with this thing. I get closer to my fingers without burning them.
I got it.
Is it still burning?
Yeah, we're still going. I'll try to catch that thing.
Yeah, when it's hot, very hot and warm, just don't burn your fingers. Keep pulling it down, pressing it in place. And it'll keep shrinking. It'll keep going down. Just got to be patient. tag in on the end, get it hot. When it's hot and you feel it's almost too hot to handle, hold it down in place as it cools. To put on, but it will go on. And you will not be able to run one continuous piece all the way up here. It will drag too hard, but you'll get a feeling for it as you do this. And you just cut it off and slide this one all the way up to the end and start another section.
And you can just use regular shrink tubing for this, correct? It doesn't have to be the special conductive shrink tubing, right?
No, this is, you don't want conductive for this.
Yeah.
This is just a protective coating. Little tip though, if you get 3-to-1 shrink tube, 3-to-1 shrink tube, well, once it shrinks, will have a thicker wall thickness. It'll offer more protection for it. And I actually got more on here than I thought I was going to before I started getting hard to pull. All right, you're not going to find it too much. I'm going to snip this off here. But when you shrink it, you just overlap the pieces so they go all the way up. Once it comes out down there, then you can grab, oh, I should put that back in the vise again. End up dragging it out the front door.
Wait.
Vise really helps keep everything arranged.
That's that thing you were talking about.
What was it, okay. Now I want this to go over the end of that, about an inch past everything. And then I'll shrink that down, put another piece on. Now I need to go about an inch past the end. About there?
Past the metal shielding? You got to keep going to get past the metal
yeah,
shielding.
I want about an inch past the shield.
Yeah.
Needs to go about right there. Damn, we're dropping everything.
I got it.
Okay. And it's best if you get the shrink tube with the sealer in it so that when it shrinks all the way down, it's got the sticky stuff that seals everything snugly. All right, now put this in here. Because the wires are twisted, it isn't particularly pretty and dead smooth, but it's more functional. Also, when you got that little hook end on it, you'll shrink this stuff way faster than without it. Now, the next piece is just going to overlap that one. Sometimes you end up with 3 or 4 pieces.
Made quite a bit of distance with that first one, though.
Huh?
You made quite a bit of distance with the first one.
Yeah. More than I thought it would get, usually in a shorter length. If you got a lot of curve in the wire harness, if you straighten them out a little bit, that helps. Something else you can do, though I usually don't do this, is spray this little silicone spray on them. It makes everything more slippery. Usually about 4 feet seems to be the best length, 4-foot sections. Too difficult, we'll just snip that off right there. Wire. Now go all the way up. There it is, just overlap it a little bit.
Oh, pushing the metal shielding.
Huh?
I pushed the metal shielding a little bit.
Oh, that's because you pull. If it bunches up, you pull on your shield, you'll pull the wrinkle right out of it.
Here we go. I got it.
But when you're pushing it on, it tends to try to bunch it up on you a little bit. Some guys would think you have to ground both. Some guys would think you have to ground both ends of the shield. You don't. So when you install the harness, this is the battery end. This has the shield ground. The other end of the shield should not be grounded unless you have a metal chassis or aluminum boat. And in that case, you would hook one up to here to the metal chassis of the boat. We don't have a metal chassis, so it's not going to carry anything.
That's a good trick.
Sometimes that making a neck down nose, it allows it to pull around other cables, so if it runs into bumps something, it makes it easier to go through.
Then after you get it through, you just cut it off, right?
Huh?
After you get it through, you
just
just
take a
cut it
razor
off.
blade, split it, peel it off on it. See, by doing this to it when it's still warm, don't pull them out. These will be taped too. In fact, I should tape those right now. But that